Hiki ni kipindi chetu cha 3 kwenye topic ya friction, na leo tunaenda kusoma kuhusu normal force and friction. Lakini pia tutaenda kudiscuss kuhusu types of friction. Now again, I am bringing you back to the paper we used to start our discussion of frictional force when I was explaining how friction does. And if you remember, we had this paper. Again, I told you that if we have the weight of the body, here there will be friction, there will be the force pulling this body to this direction. And then frictional force, we tend to pull it back. In the previous session, we said, according to laws of friction, this frictional force will be directly proportional to the normal reaction R. And we said that according to laws of friction, frictional force F will be equal to coefficient of friction mu times normal reaction R. Now we are coming to explain what is the normal reaction R. So let's go together. As I said in the previous session, at the part of introduction, the normal force is the net force compressing two parallel surfaces together. So, for example, if I have this, my mathematical set, when I put it above the exercise book, there will be a force compressing between this mathematical set and the exercise book. And this force is the one which we are calling it the normal reaction. So this force which compresses between this mathematical set and the exercise book increases with the weight of this mathematical set. As increasing the weight of this mathematical set, then it will be very difficult to lift it, simply because of the normal reaction which compresses the two surfaces together. So we are saying direction is perpendicular to the surface. Direction of the normal force is perpendicular to the surface. For example, in our diagram, as you can see, the surface is horizontal, direction of normal reaction is perpendicular, makes an angle of 90 with the surface. For a mass M resting on a horizontal surface, the only component of normal force is the force due to gravity, where Fn, that is the normal reaction, will be equal to mg. For the mass resting on a horizontal table, Fn will be equal to mg. So, for all cases which will be solving the questions for the mass resting on the horizontal table, we will be using normal reaction R is equal to mg. So we are saying in this case, magnitude of the frictional force F is given by F is equal to mu R. That is to say, we have already derived this from the laws of friction, that F is direct proportional to R. So F will be equal to mu R, but R is equal to mg. So F will be equal to mu mg. Ndivyo ambavyo F itaonekana. That will be the magnitude of frictional force. Now, if the object is titled over the inclined plane, what is an inclined plane? I know you have studied it in your form 2 physics, somewhere in a machine. Now in this topic we are going to repeat what you discussed in your form 2 physics. Now let's say my ruler, I take an example as my inclined plane, and I have the body which is my modem, which I put it on the inclined plane. Look at this case. If I start lifting the ruler, that means now the angle between ruler and the horizontal is 0. But if I start lifting this ruler, the angle between ruler and the horizontal starts to increase. Now look at this example. Angle is increasing, but still the modem doesn't slide. Angle is increasing, you see. Now inaweza kuwa imefika hata 20. Ila the modem does not slide. Now I want to explain, if it reaches a certain angle, the modem slide. Now, I want to explain about this. However, we'll discuss it in detail later. But the reason behind it that the frictional force pulling this modem upward depends on the angle in this case. So, having our inclined plane like this way, this is our inclined plane, then having the block resting on the inclined plane like this way, then from there we'll have the weight of the object pulling straight downward, weight of the object mg, and the normal reaction which is perpendicular to the surface, normal reaction r. So from there, manake, if we resolve this, remember the resolution of vectors. If we have an angle theta, and this angle is equal to the angle theta which is between horizontal and the inclined plane, theta. Kwa hiyo hii angle itakayokuwa hapa theta kati ya horizontal na inclined plane ndio sawa na angle theta pale. Sasa kama tuna angle theta, mg tukimresolve kwenda pale itakuwa ni mg cosine of an angle theta. Na ile pale tukimresolve kwenda pale manake the horizontal component we have a component parallel to the plane itakuwa ni mg sine of an angle theta. Wakati huo kama hiyo block watakuwa wamerest tu pale, manake lazima frictional force itakuwa inamvuta kwenda juu. Sababu block as we increasing the angle anaweza kashuka huku chini. So frictional force F is, let's call it static because block wanakuwa ha move, so inakuwa ni static friction. Tutaenda kusoma types of friction hapo mbele. Kwa hiyo sasa tunachokisema hapa ni kwamba initially huyu force anakuwa ni mkubwa kuliko huyu, but this force tend to increase with the increase of this, tend to increase with the increase of this angle. Kwa hiyo in order for the block to slide, in order for the block to slide, then mg sine of an angle theta inatakiwa iwe sawa sawa na iwe greater than or equal to fs. Huyu force anapokuwa iko na huyu, akianza tu huyu kuzidi, hii ina slide kwenda downward. Sababu huyu anavuta kwenda hivi, anavuta kwenda hivi. So hizi ni two vectors. Ila kama huyu akiwa mkubwa, hii block haita slide. So but mg sine of an angle theta increases as theta increases. As the angle theta increases, then the component mg sine of an angle theta also will increase. So finally, we'll end up with this force increases as the angle increase. No matter tutakapokuwa tunazidi kuiongeza, itakuwa inaongezeka. So in case of inclined plane, the normal reaction R is not mg again, but it is mg cosine of an angle theta. So since the normal reaction is mg cosine of an angle theta, R in this case will be equal to mg cosine of an angle theta. Then what we are saying that the normal reaction in the inclined plane has decreased because some part of the weight does not act perpendicular to the surface. So we are saying that the normal force is less if the object is titled in the surface, such as inclined plane. The normal force is less because less of the force of gravity is perpendicular to the surface of the plane. Therefore, the normal force and ultimately the frictional force is determined by vector analysis. So for example, in this diagram we have resolved the vector by methods of vector analysis. We have resolved this vector into the component perpendicular to the plane and the component parallel to the plane. So this component which is perpendicular to the plane is the one which is regarded as the normal reaction R, So this marks the end of our session. In the next session, we will discuss about the types of friction. If you have any question, you can ask me. If you have not understood anything, you can ask me. Thank you.